Everyone, today we are going to look over this question. It is called minimum changes to make alternating binary string. So in this question we are given a binary string of zeros and ones, and we are asked the minimum number of operations such that the operations are that we can choose one character in the string and reverse it. If it is 0, then we can make it 1, or if it is 1 we can make it 0. So using these operations, what is the minimum number of operations which we can apply to a string to make it an alternating pattern of 1010 or 0101, so like that. And we have to return that the minimum number of operations as a result. For the strings which are already as 101010 or 010101, for those we have to return the answer as 0 only. So before we move on to the code and see how I have written it, let's first understand the intuition and approach to solving this problem. And I already have two test cases in my notes to explain it to you. So moving on to the test cases, see, what we have been asked is that we have to convert this string into a pattern of 1010 or 0101, and we can do only one operation, that is we can pick a character and either make it 1 or we can make it 0, and each operation counts as one operation. So every time you do it, it will count as 1 for every character for every index you do it. So our aim is to determine which operation would be more feasible, to converting it into this pattern or to converting it into this pattern. See, we will kind of apply some operations we know, like we can make it 1100 if we change this 0 to 1, or we can make it 0100 and change this 0 to 1. And here our task is to determine the minimum number of these operations so that we can convert this string to either a pattern of this or this, so that it could be an alternating binary string. But to decide which pattern to convert it into and the minimum number of operations we need to convert it into either of these patterns, we would have to check it like for each one of them. For both of them we have to check, and how you would check is like we would compare our original string with each of the pattern that we are supposed to make. So if we compare the first character of the original string and this first pattern, you would see we require 0 number of operations for the first character, 1 operation for the second character, second 2 operations, like one more operation for the third character, and one more operation for the fourth character. To convert this 0 to 1, one operation; to convert this 1 to 0, another operation; and to convert this 0 to 1, another operation. Is that fine? So total number of operations are 0 plus 1 plus 1, that is equal to 3. But is it our answer? No, we cannot confirm still, because we have to check for this pattern also, 0101. So how we would do that? We would compare this original string with this. The original string is 0100. You would compare it with the second pattern string also, that is 0101, and the answer we got from our first pattern we would store it in a variable called start1, meaning for the pattern which starts with 1 we keep the answer as 3, the number of operations required as 3. Now for the second pattern we again do the comparison, and we find that the number of operations required for the first index is 1, for the second index is 0, for the third index is 0, and for the fourth index is also 0. So the total number of operations required to convert it into the second pattern is 1. So to convert it into a pattern where the pattern starts with 0, that means the pattern is like 0 1 0 1, and for here the pattern is like 1 0 1 0. For the one with 0 1 0 1 we only need one operation, whereas for the pattern which that starts with 1 0 1 0 we need 3 operations. So which is more feasible, one operation or 3 operations? Obviously one operation is more feasible, so we will compare these two variables and return the minimum of them as the answer. Okay, now let's take another test case so that we could understand it more better. Now for this test case we have two patterns again, one that starts with 1 1 0 1 0 1 0 1 0, and another pattern that starts with 0, that is 0 1 0 1 0 1 0 1. These are the only patterns of the alternating binary strings. There are no other way you could make an alternating binary string. Is that okay? So this is the pattern for the variable start 1, in which we will give a number of operations, and this is the pattern for the variable start 0. And now we compare this string with both the patterns so that we can get the number of operations for each variable. So if we compare the first characters, the number of operations required is 0. For second character the number of operations required is 1. For third character the number of operations is required 1. Fourth character 1. Fifth character 1. And for the sixth character 1. And for the seventh character it is 0. And for the eighth character it is 0. So the total number of operations that are required in this case for the first pattern is 5 operations. So we store this value in our start1 variable. Now for the second case, we compare this original string with the second pattern, that is 0 1 0. Now on comparing we find that for the first character we need one operation, for the second character we need no operations, for the third character we need no operations, and so on. We need no operations till the sixth character, and for the seventh character we need one operation, and for the eighth character we need one operation to convert 1 to 0 and 0 to 1. Okay, so the total number of operations required are 3 operations, and we store it in our start 0 variable. Now we compare these two variables and we find that the minimum number of operations required are 3, and return this value as the answer. Now moving on to the code that I have submitted for this question, I will explain it to you step by step what I have done. Here I just have taken the length of the string, and this is our start 0 variable, and this is our start 1 variable. Now what I do is I iterate over this whole string, and for every even indices the first pattern, that is 0 1 0 1 0 1 0 1, this assumes that the zeros lies at the even indices and the ones lie at the odd indices, whereas the second pattern assumes that the ones lie at the even indices and the zeros lies at the odd indices. So according to that, I iterate through the original string, and wherever I find in an even index if the character is 1, then for the first pattern, that is 0 1 0 1 0 1, there is a mismatch with the original string. So we increment the count of operations for the first pattern string, that is start 0 string, with 1. Else if I find it as 0, That means it is a mismatch for the second pattern string, that at the odd indices it should have been 1 but it is actually 0. So in that case I increment the count for the second pattern string, that start 1, I increase it by 1. Similarly, if the indice is odd and the character is 0, then at the odd indices the character should have been 1 for the first pattern string, that is 0 1 0 1 0 1 0 0 1, but it is actually 0. So there is a mismatch for this with the original string. So here we have to increment the number of operations for the first pattern string, that is start 0 by 1. Similarly, if it is 1 actually in place of 0, then what happens, there is a mismatch with the second pattern string, because the second pattern string wants that at the odd indices it should have been 0 instead of 1, but it is actually 1. Si is equals to 1 in the else case. So we increment the start 1 for the second pattern with 1. After we have calculated the total number of operations to convert the original string into the first pattern and the second pattern, we take the minimum of them and return it as the answer. I hope my explanation would have helped you, and if this helped you in any way, please make sure you like, comment and subscribe to my channel, and till then see you in the next video.